Hello guys, and welcome to another video. So in this video we'll be looking at questions based on electric circuits. Starting with this one, it reads that which one of the following is the equivalent unit for the potential difference? And to answer this question, we need to know what formula is used to calculate potential difference, and that formula is P is equal to W over Q, where this W is the work done to transfer our energy and this Q is our charge. And what we will do is to write the units of these two quantities, and W is the energy, and energy is measured in joules, whereas Q is our charge and it's measured in coulombs. But what we know is that this coulombs is to the power of 1, and what we are going to do is to take this coulombs up where this joules unit is, and if we do that, the one that is positive will then become negative when we take this coulombs up. According to the laws of exponents, if we take something up, it changes its sign, right? So here what we will then have is joules per coulomb, which is J dot C to the power of negative 1 joules per coulomb. So that's the unit for your potential difference. That means our answer will be C. Okay, now we move on to the second question. The second question says a battery with a potential difference V is connected to resistor R. Ammeter connected in series is shown in the circuit diagram below, and these are our circuits. There are two, but the one they're telling us about on this statement is this one here. Okay, and then they talk of the second one. The second one is this one on our right. So with the second one, they're saying that a second resistor of the same resistance is now connected in parallel with resistor R. So on this resistor, we are now adding this resistor here. We are adding this resistor, and the diagram, as you can see, is this one on the right. And then they ask us, how will the voltmeter and ammeter readings change when the second resistor is connected in the circuit? Well, this is what we know, guys. Firstly, what you will realize is that when we add the second resistor, it means our connection is going to be now a parallel connection, and we know that in a parallel connection we are supposed to have the same voltage, okay, or potential difference. So the potential difference will be the same, right, for both resistors. And then another thing that we need to know is that if we add another resistor in a parallel connection, or to form a parallel connection, the more resistors we add in parallel, the less resistance we are going to have. The total resistance in parallel decreases. So if we look at the relationship between resistance and current, it's going to be inversely proportional. That means if what happens here in terms of our resistance is that the resistance will decrease due to us having added this resistor in parallel, then that means the current has to increase. So the options that we are going to look into in terms of the voltmeter and ammeter readings have to do with the current increasing and the resistance, the voltage being the same. So here we see that current increases, but the final nail in the coffin is us finding out what happens with the voltmeter reading. The voltmeter reading, guys, does not decrease in a parallel connection, but it stays the same. So the correct answer here is going to be D. Okay, that's how we answer our multiple choice. Now we go to the long question. So in this question, guys, they say the diagram, okay, let me change my point. The diagram shows the three resistors connected to the battery, the ammeter and high resistance voltmeters V1 and V2. The resistance of the ammeter, conducting wires, and the battery is negligible. Then we go to our questions. The first question says we have to state Ohm's law. So Ohm's law, guys, is as follows. It says that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. Or sometimes you can start with current and say that the current in a conductor is directly proportional to the potential difference across a conductor provided that temperature is constant. But yeah, that is your Ohm's law. So that's how you state it basically. Now let's look at the second question. 5.2. 5.2 says, okay, let me just fix this. Okay, before 5.2, there's a statement here. It says that when the switch S is closed, the current passing through the 6 ohm resistor is 0.8 amperes. So guys, the first question here says we have to calculate the effective resistance of the parallel combination. And the effective resistance is basically the total resistance here. Well, it's the overall resistance that is in terms of the parallel connection. So this is how we are going to do that. There are two formulas we can use, guys, and I'm going to show you both. We'll start with this one because it's very much quick. Rp is equal to R1 R2 divided by R1 plus R2. So this one, guys, we use if we only have two resistors, as you can see there. And if I substitute, R1 is 6, so this is what I treat as R1, and this is what I treat as R2. R2 will be 5 divided by 6 plus 5, and this is going to give me 30 divided by 11, and the answer I'm going to get here when using my calculator is 2.73 ohms. Never forget to write the unit, guys. And this is how we are going to find the resistance here in parallel using this formula. That's option number 1. I'll show you the second option. The second option, guys, is for us to use the formula 1 over Rp is equal to 1 over R1 plus 1 over R2, and then what we are going to do is to substitute. So what we'll have is 1 over R1 is 6 plus 1 over R2, which is 5. And if we deal with these numbers, they should give us 11 over 30. So if we put all of this on the calculator, what you are going to get is 11 over 30. But if we are doing this calculation, we must then invert this 11 over 30. So this one we have to invert, and us inverting means that we are writing this in an opposite way. That means this 1 over Rp when inverted will become Rp is equal to this 11 over 30 will become 30 over 11, and the answer when you put this on the calculator will be 2.73 ohms. So you can deal with this question using either of those two ways. Let's move on to the second one. So 5.2.2 says we have to find the reading on V2. And for us to find the reading on V2, guys, we need to check where V2 is connected. And what you will realize is that V2 is actually connected to the two resistors that are connected in parallel. And that means that the voltage we find on the 5 ohm resistor and the 6 ohm resistor is going to be the same, which is this voltage on V2. Okay, then for us to find the reading on V2, we will remember that we have the ammeter reading on the 6 ohm resistor. They told us that the 6 ohm resistor has a current of 0.8 amperes. So we are going to use that information to find the reading on V2. So we can use the formula V2 is equal to the current on the 6 ohm resistor multiplied by the resistance of 6 ohms. Yeah, this 6, guys, is showing that I'm working with the 6 ohm resistor. So the current on the 6 ohm resistor is what? 0.8, and the resistance there is 6. So if I multiply these two numbers, then the answer I'm going to get is 4.8 volts. So this is how I'm going to get my V2. All right. Now we'll have a look at 5.2.3, and it says we have to find the reading on the ammeter. So guys, for us to find the reading on the ammeter, we have to understand how this reading on the ammeter works, and that's the current, right? So the ammeter in question is this one here, which I've highlighted in yellow. That's our ammeter. And we know that in these circuits we have what we call conventional current, and conventional current is the type of current that flows from the positive terminal going into the negative terminal. So this is how our current is going to go. It's going to move here from the positive terminal going to the first resistance part, because there are two resistors which are connected in parallel. It's also gonna split itself up to the 5 ohm resistor, and then it's gonna pass through the 5 ohm resistor, go there. This one as well in the 6 ohm resistor will pass through the 6 ohm resistor, connect with the one coming from the 5 ohm resistor, and then they will combine again to form one current. Then they will pass through the 3 ohm resistor and then back into the ammeter, then the negative terminal, and then it becomes a cycle. But what I want you to notice is that when this current of ours flows into the parallel resistors, it divides itself. Firstly, it has to distribute itself through it has to distribute itself to the 6 ohm resistor, and then it also has to distribute itself to the 5 ohm resistor. So that current is actually the total current. All right, that's the total current. But what we know is that we already have the current on the 6 ohm resistor. So what we need to do is to find out what is the current on the 5 ohm resistor. And once we find that current, we are going to combine it with the current on the 6 ohm resistor, which would give us our total current, since that current was divided. I hope that makes sense. So the formula then we are going to use, or rather let me say, this is the way in which we are going to find the current on the 5 ohm resistor. We will remember that we found the voltage here, V2, and we said the voltage that is on V2 belongs to both the 5 ohm resistor and the 6 ohm resistor, and that voltage here was, the voltage here was 4,8. So this is what we are going to use to find the current here. The formula we'll use is V, I'll say V2 is equal to I5, the current on the 5 ohm resistor. The 5 is for the current on the 5 ohm resistor. Then we'll say R5. I think you now know what these numbers at the bottom mean. And then our current is what we are looking for. We know what V2 is. V2 is 4,8. Current is what we are looking for. Our R5 is the resistance, which is 5 ohms. Then we will divide by 5 on both sides. They cancel here. So our I5 will be equal to, our I5 will be equal to 4,8 divided by 5, which will give us 0.96 amperes. But this is not the current we want. We want the current flowing on the ammeter, and that is the total current. And what do we do to find current in terms of the parallel circuit? We use the formula IT is equal to, we have the current on the 6 ohm resistor, so I will say I6 plus the current on the 5 ohm resistor. So I'm going to say I6 plus I5. I6 is this one here that we are given, which is 0,8 plus I5, the one that we just found, which is 0,96. And if we add these two together, what are we going to get? The calculator is going to give us an answer of 1,76 amperes. So this is the current on the ammeter A. I hope, guys, this makes sense. If you don't understand, you just have to play back the video so that everything I'm explaining makes sense. Let's move on to the next question. The next question says we have to find the amount of charge passing through the ammeter in 10 seconds. So this one will answer as follows. For us guys to find the amount of charge, we know that charge is found using the formula Q is equal to I multiplied by our delta T. So we are looking for Q, and the current that they are telling us about, let me just go back to the question. They are saying we have to find the amount of charge passing through the ammeter. So the amount of charge passing through this ammeter here highlighted in yellow, we know the current on that ammeter, right? It's the one that we just found, which was 1,76 amperes. So we are just going to substitute that current here, 1,76, and multiply it by the time given. We were given the time of what? 10 seconds. And if we multiply these two values together, they are going to give us a charge of 17,6 coulombs. And that is how we find that charge. All right, move on now to the next question. The next question is 5.2.5, and it says we have to calculate the reading on V1. So to answer this one, guys, we need to understand something about the reading on V1. So now we are looking for the reading on V1. This is V1, where the one which we are being asked to find the reading of. So V1, guys, is where we get the total potential difference, so the total voltage. It comes from the cell. Okay, that's where we get our total voltage. So what we know at the moment about this circuit is that we have V2. Okay, we have V2. Remember, we found V2, and V2 was 4.8 volts. So what we know is that, okay, we have V2, but for us to find the total voltage, we also need to know what is the voltage on this 3 ohm resistor. Okay, we need to know what is the voltage on this 3 ohm resistor, but that's one way of doing this. We have two ways of actually answering this question. So I'm gonna start with the easy way. The easy way is to remember that we have the total ammeter, and the total ammeter is this one that I wrote here, which is 1.6 amperes. And we also have we have the total ammeter reading, which is 1.76. We can also find the total resistance. Okay, so the total resistance we can find as follows. We will remember that we had found the resistance in parallel, and the resistance in parallel was equal to let me remember, the total resistance in parallel was equal to 2.73 ohms, right? So what we can do is to say, okay, the total resistance then is equal to the resistance in parallel plus the resistance in series. The resistance in parallel is this one, which we found to be 2.73, and the resistance in series is this 3 ohm. So we are going to add those two together. Our RP is 2.73 plus our RS, which is 3. All of these will add up to 5.73 ohms. Once we find this total resistance, we will use the Ohm's law formula rather, which is RT. I'm just going to say RT is equal to V1 divided by IT. RT is the total resistance. Okay, and then when I substitute, my RT is this 5.73 is equal to my V1 is what I'm looking for, and I will have my IT. My IT is this total current, which is 1.76. Then I will just cross multiply there. Let's say V1. If I cross multiply, I'm saying V1 times 1 gives me V1 is equal to, and then I'll say 5,73 multiplied by 1,76, and the answer I get here is going to be 10,08 volts. Okay, when I round off to 2 decimal places. Okay, so you just press your calculator there to get your answer. You say V1 times 1, you get V1, 5,73 multiplied by 1,76, and this is the answer you are going to get. That's the first way to get to the answer. I'm gonna show you the second way. Okay, so the second way, guys, will be as follows. Let me remove some of this stuff here because it looks a mess. So remember, we are looking for the reading on V1, and the second way to find that V1 is to actually find our total voltage. Okay, and we are going to use a formula which I will show shortly. So what we know, guys, is that we already have V2, right? And if we have V2, we know V2 belongs to the parallel connection, but the question is, what is the voltage here? We don't know the voltage on the 3 ohm resistor, so we can find the voltage on the 3 ohm resistor. We also remember that in terms of this ammeter of ours, this ammeter, the reading that is gonna flow on the 3 ohm resistor is actually the reading that is on this ammeter. So the resistor of 3 ohms has again a current of 1,76 amperes. Okay, so we are gonna use that information. So I'm gonna say V, this 3 ohm is connected in series, so I'm gonna say Vs for the voltage in series is equal to the current on the 3 ohm resistor multiplied by the 3 ohm resistor. You know what these numbers mean, right? They mean I'm focusing on this 3 ohm resistor. The current on the 3 ohm resistor is 1,76 multiplied by the resistance of this resistor, and that's 3. So we are going to multiply these two numbers, say 1,76 times 3, and the answer we get is 5,28 volts. This is the voltage in series. So what we have now is the voltage in series, and then we also have this voltage in parallel, which is V2. So what I'm gonna say is that the voltage, total voltage, is equal to the voltage in series plus the voltage in parallel, which is V2. So V2 is also the voltage in parallel. I hope you understand that. Then I will combine the two numbers together. I'll say the voltage in series, which is this one, 5,28, plus the voltage in parallel, which is this 4,8. And if I add these two numbers together, the answer that they are going to give is 10,08 volts. So that's another way of finding our total voltage, which is V1. In fact, instead of saying VT, maybe I should say V1, or I can say therefore V1 is equal to 10,08, since they said I must find V1, but I know that V1 is actually the total voltage. So yeah, that's how you answer this one. Let's go to the next one. Okay, now we are looking at 5.3. It says define potential difference across the ends of a conductor. Okay, so the definition is as follows. So the definition for potential difference, guys, is that it is the energy transferred per unit electric charge flowing through it. Right, that is the definition. Now let's look at 5.4. 5.4 says we have to calculate the work done in moving a charge of 9,6 coulombs through the 5 ohm resistor. The first thing that we need to understand about 5.4 is the type of formula we will use, and that formula is going to be V is equal to W over Q. And then this formula we can manipulate from here, guys. If we manipulate it, remember, you always have to write the formula according to what we have been given on the formula sheet. So this is how the formula is given, and then we can manipulate it to say W, which is the work done, is equal to V multiplied by Q, right? Then from here we are going to substitute, but V is what? It's the potential difference, and if they are saying we have to find the work done in moving the charge through the 5 ohm resistor, that means we have to use the potential difference of the 5 ohm resistor. And you will remember, guys, that we had actually found the 5 ohm the 5 ohm potential difference. That potential difference was the one we found here on V2, which is 4.8 volts, right? Since the 6 ohm and the 5 ohm are connected in parallel, they are going to have the same voltage. So that's what we are going to use to answer this question. We would use the 4.8 voltage or potential difference. So where I see V, I'm going to substitute with 4.8, and this Q is this charge here that I've been given, and that charge is 9.6 coulombs. So I'm going to substitute here by 9.6, and then from there I'm going to get my answer, and my answer will be 4.8 multiplied by 9.6, which is 46.08 joules. And that's how we answer this question, guys. I hope you enjoyed the video, you learned a lot from it as well. And please, guys, do be kind in sharing the video with your friends. Also, please be kind in terms of liking the video and subscribing to the channel to get more learning content like this. I'll see you on the next one, guys. Bye bye.